Living Off the Land in Space, The Power of ISRU. Written and narrated by Isaac Arthur, NSS President. To settle strange new worlds on that final frontier, humanity must become more than visitors. We must become residents, and that means learning to live off the land. In space, that concept is called In-Situ Resource Utilization, or ISRU. It's the key to unlocking long-term survival and thriving off Earth, and the National Space Society believes it is one of the most critical areas for space development in this century. I'm Isaac Arthur, President of the National Space Society, and in this episode we'll take a high-level look at how ISRU turns dead rocks into living frontiers, and why it is essential for everything from moon bases to Mars cities and deep space exploration. For a full deep dive, check out my longer episode on ISRU over on Science and Futurism with Isaac Arthur. And our magazine, Ad Astra, has countless articles focusing on ISRU areas. At its core, ISRU means using the materials and energy you find on site, whether that's regolith under your feet on the moon, the water ice in a Martian crater, or the sunlight shining in from the sun. The more we can use local resources, the less we need to haul up from Earth, which dramatically lowers cost and increases mission sustainability. Some things like microchips are so valuable, pound for pound, that even the out-of-this-world cost of getting them off this world isn't too bad. But other things, like bulk material to protect us from radiation and micrometeors, represents a category where every shovelful an astronaut throws over a moon-based habitat saves us thousands of dollars. But ISRU is about more than saving money. It's about independence. Every kilogram you launch from Earth is one more step toward building self-sufficient colonies and industries in space. Whether you're supporting a robot mining base on an asteroid, or planting the first crops in a Martian greenhouse, ISRU is what makes that possible. So what exactly do we want to do in situ? Let's look at the major categories. 1. Shelter. Before you can breathe, you need protection. Space is filled with radiation, temperature extremes, and micrometeorites. ISRU means finding or building shelter from local materials. That could be digging into a crater or lava tube, inflating a temporary habitat, and burying it in the regolith, or even constructing igloos of water ice on cold worlds. Early shelters might start as landers or inflatable tents, but even these benefit from ISRU, such as shoveling local dust onto the tent for radiation shielding or melting ice for structural support. Later, we might use machines to compact regolith into bricks or 3D print entire habitats out of local soil. 2. Volatiles. Volatiles are materials that evaporate easily, like water, carbon dioxide, ammonia, or methane, and they are essential for life. Water can be split into oxygen to breathe and hydrogen to use as fuel. It also makes a great radiation shield from its hydrogen content, which is also true of ammonia and methane, which can be turned into fertilizers or even rocket propellants. Many of these are abundant in the outer solar system, and maybe even in permanently shadowed craters on the moon. For most spaceships and space station designs, the supermajority of the mass is shielding and fuel. ISRU sourcing of those, especially for return trip fuel, makes spaceflights vastly cheaper and safer by allowing more robust missions to be launched. Where ices are rare, we can extract volatiles from rock. Lunar regolith, for instance, is rich in oxygen bonded to minerals. With the right technology, we can liberate that oxygen and use it for breathing or oxidizer. And we have options for metallic fuels or thermite. 3. Energy production. You cannot process volatiles or build shelters without power. Luckily, space offers multiple options. Sunlight is abundant in the inner system, and solar panels can be supplemented by solar concentrators or thermal receivers. Local materials can help here too. Metal mirrors, wires, and structures built on site can reduce the mass we need to bring from Earth. Silicon, the bulk material of solar panels, is readily available, and being able to produce those on site, while more difficult, would further assist in space development. 4. Manufacturing and construction. Once you have energy and basic materials, you can build. That might start with simple 3D printing using regolith-based inks or polymers made from methane or leftover plant materials from food grown on site to make tools, bricks, or spare parts. Over time, more advanced smelting and manufacturing systems could create everything from solar panels to circuit boards. Local manufacturing isn't just about survival, it's the foundation of a thriving economy in space, and it will evolve from survivalist tinkering to large-scale production that trades goods between habitats, planets, moons, and asteroids. 5. Agriculture. It's not just our facilities that need fuel, it's our astronauts too. Growing food off Earth is one of the most challenging and rewarding goals of ISRU. It's slow to set up, but eventually necessary for long-term missions and large populations. Early crops may be grown hydroponically in small greenhouses, or in algae tanks that also help scrub carbon dioxide and recycle water. Soil might be manufactured from regolith and organic waste. Over time, entire habitats may resemble farms, and dedicated agricultural stations could emerge, just like farming towns on Earth that feed entire cities. 6. Propellant production. Perhaps surprisingly, propellant is one of the most valuable products in space. Even if you're not moving around much, having fuel lets you land, take off, rendezvous, or adjust orbits. On Mars, water ice and atmospheric CO2 can be turned into methane and oxygen for rockets. On the Moon or asteroids, we might use electrolysis or other chemical methods to generate fuel. For advanced systems like ion drives, nearly any material can be used as reaction mass. ISRU lets us refuel in space, which is essential if we want to go further than a one-way ticket. ISRU isn't just science fiction, it's happening now. NASA's Artemis program includes plans to demonstrate lunar ISRU. Robotic landers are testing soil chemistry and ice deposits. Private companies are developing oxygen extractors, 3D printers, and solar panel deployers for the Moon and Mars. At the National Space Society, we see ISRU as one of the cornerstones of space settlement. It's how we go from fragile outposts to thriving space communities. And as we learn to reuse and recycle more in space, we are also learning how to better manage resources here on Earth. For a deeper dive into each of these topics, from shelters to agriculture to extracting fuel from rocks, check out the full episode over on my channel, Science and Futurism with Isaac Arthur. Until next time, keep looking up and thinking ahead. Ad Astra.